Ladies and gentlemen, on 2.1.1, we are told that the first term of an arithmetic sequence is 7. So that is A equals to 7. The common difference is 5, that is D is equals to 5. And the series has 20 terms, that is N is equals to 20. And we have to calculate the sum, that is 2.1.1, okay? So let's see. We know that the formula of the Sn for arithmetic series is given by Sn is equals to n over 2, 2a plus dn minus 1. Usually on the formula sheet they put the d there, but I don't prefer to put it there, né? Because if d is a minus, learners usually make mistakes. So always put your d on front. It's fine. And then now we can plug in S20 would be 20 over 2, which is 2, then 7, plus 5, 20 minus 1. You can see, ladies and gents, that I just aligned the n with the n, the 5 with the 5, the a with the a, the 20 with the 20, with the n, and then there with the there from the given information. And then plugging this into your calculator, it should give you 1090. All right, perfect. Now let's go to 1 point. Oh, I'm going to erase this one. I'm going to erase this one. Let's just remove this. Okay. How do we remove this again? Okay. Let's see one more time. Okay, no, let's just do this, ladies and gents, to save time. So we have 2.1.2. On 2.1.2, things get juicier, right? The series is extended to 75 terms, and the total sum of this 75 terms is 14,400. We need to write the expression using sigma notation for the sum of the terms added beyond the original 20 terms. All right, perfect. So here, let's break it down step by step. At first, let's find the formula of the general term, which is step 1. We know that the Tn is given by a plus d n minus 1, which is going to be 7 plus 5 n minus 1. Foiling the 5 in gives us Tn equals to 7 plus 5n minus 5, which end up simplifying to 5n plus 2. All right. And then we are told that the sum of the total sum of 75 terms is 14,400. Right. Let's do that. So I'm going to say, okay, the S of 75 terms, we are told to be this figure, right? And we solved the sum of 20 terms to be that figure. Therefore, the sum of terms from 21 to 75 will be S is equals to sum of 75 terms minus sum of 20 terms. Right. Does it make sense, ladies and gentlemen? I need to go back and read the question again with you so that you understand what I'm actually doing here. They say the original arithmetic, oh, let's use this thing. The original arithmetic series is extended to 75 terms. So we have 75 terms now in total. Ne? The sum of this 75 terms is that. So which means all the terms added together from term 1 to term 75, it's 14,400. Ne? Using sigma notation, write down an equation for the sum of the terms added to the original series. Remember, the original series only had 20 terms. So now, which means we added how many terms? We added 55 more terms, which means from term 21 to term 75. Ne? Because we had term 1 to term 20 before. Do you see it? So if I need the sum, obviously I am going to indeed subtract. Ne? I am indeed going to subtract this. Right? So, which gives me 14400 minus 1090. And pressing that into your calculator, you get 13,310. Yeah? Now we need to plug this into sigma notation. Remember sigma notation is sigma. Remember we started from term 21 because we just need to represent the terms which were added to the series. Ne? We had term 1 to term 20, so we're not going to show them here. So we're just going to start from 21 up to 75. You always show where you are starting, where you are ending. And here you must always show your Tn formula in brackets, ne? Which is 5n plus 2. Okay. And then you show what the sum is equals to, which is 13,310. Right, ladies and gentlemen. And that is the answer to this question. I hope it makes sense, ladies and gentlemen. All right. And then let's go on now to the next question. Let's go on to the next question.